Yes.
Okay, so good day all. So you have started introduction to NLP, meaning you've seen what NLP is all about. It's a little divergent from the actual data science you've been doing, where you deal with numbers that describe data. If they are not numbers, maybe you deal with text that is expected also to be converted to numbers. So maybe in your data points, you see there are fields of, let's say, sex that is in either M or F, or male or female, that is being converted into discrete numbers. And you are basically trying to predict something along the line of either regression or classification. So you've seen that. So a little divergent is natural language processing, where all of the things that you will be working on are textual content, or voice content, or video content, or a mixture of both in multimodal settings. So the natural language processing, as the name entails, what we'll be seeing today, a quick go through the introduction, its applications, some subfields in NLP. In the curriculum, I see that you will be touching translation, although basic, or even some form of translation, and then sentiment analysis, where you'll be classifying some movie review. So in this week, we'll touch on some introduction to translation. But subfields, there are many subfields in NLP, as we'll be seeing during the course of the presentation. And then some text processing methods that are used on textual data when doing natural language processing, some libraries that you will be coming across, challenges in the area of NLP, then the translation itself, and some conclusions, which will just summarize what we've seen during this presentation. So what is NLP? So you might, you all know NLP, because if you don't know how NLP works, but you've seen NLP, either from ChatGPT, most of us have seen what ChatGPT is capable of, but you know your phones, all these assistants that will be asking you, how can I help you? When maybe you press your earpiece or whatever, there are voice recognition, especially on Google search, where you can dictate what you want Google to search for you. So these are all applications of NLP. So we know NLP, but what is NLP? So NLP is a branch in computational linguistics. So we all maybe came across one or two persons that they will tell you, I'm a professor in linguistics. So what do? They study human language. They study how human language is created, how human language is interacted with, how human language evolves, and the rest. So that's basically what we do in computational linguistics. So computational linguistics is just the using of computer instead of human beings to understand and process human language. So a professor in linguistics, so maybe we'll have a computer professor in computational linguistics, which we are capable of, because there are these large models. So far, ChatGPT can be classified as a professor in the area of computational linguistics because it knows a lot. So natural language processing is just the name that is used in the area of computational linguistics to determine how to understand and process human language. So if you see, all the definition are both the same, but one is the actual studying, while the second one is the field that enables studying this type of things. So natural language processing is a field, and its focus is just to allow or enable or facilitate the use of computers. On computers, we mean computers and phones and cars and whatever that can understand, process, and make meaning into human language. So there are various applications, as you know. There is enhanced human-computer interaction, which you all know. So human-computer interaction, especially, let's say, chatbot, especially voice recognition, that you ask, it gives you answer, or it gives you whatever. So the basic or most common example is the chatbot. So text understanding analysis, information retrieval, and such. So especially in your Google search, you give Google something in either a different language or even some set of sentences, and it gives you something that is related, although not word for word. So it gets the meaning that is within your search query, and then it gives you everything that is relevant to it. Some of us, or some of you guys that participated in the Cohere AI, you saw something regarding semantic search. So it's all under NLP. There is a language translation, analysis of sentiment, user experience, automating customer service, and the rest. So I think there is this bank, Zenith Bank, that have Ziva. I think, is it Ziva or Ziza or whatever it's called, that it's a customer care service agent that will enable you to get some of your basic tasks done. So there are many also applications in healthcare, fraud detection, especially email spamming and intrusion detection and whatever. So many applications of NLP, as I know, most of us have come across, or if not all of us have come across this type of application. So I saw some things in the chat. Yeah, Ziva, there is Leo in UBA. Thank you, Faisal. So these are some of the applications. So subfields in NLP. So NLP is a huge umbrella that have smaller fields on it. And all of these areas are fields that are active area in research. So you can have something like sentiment analysis, which in this group, we have a lot of experts in there. We have Simonu that is focusing on hate speech, which is a form of sentiment classification. We have Dr. Shamsuddin that did his PhD on sentiment analysis and the rest. So we have name entity recognition, text classification. So sentiment analysis is an example of text classification, but text classification also is a huge umbrella that have all of this. You can have text classification that will classify either queries of customer service, or will classify types of news or whatever. So we have information extraction, question answering, machine translation, summarization, language generation, dialogue systems, as in the chatbot, and the rest, speech recognition and synthesis. There are many of them, and these are just some of the example of subfields in NLP. So we all know that, but I think most relevant is sentiment analysis and the translation, which you will see in the curriculum. So text pre-processing. So usually when you are given text, as a sequence of words. So a sequence usually is a sentence in the parlance of natural language processing, meaning if you have an example of, let's say, angry people are not always wise. So this is a sequence. You can call it a sentence. So first, what do you do? Most pre-processing in natural language processing starts from tokenization, but not all of them. Some of them require you, let's say, doing down casing, because if you have angry people are not always wise, some tasks such as sentiment analysis will require you, or most at times require you to make this A in angry a small letter, so that whenever it sees angry, it doesn't confuse itself with different cases of angry. So if you have a word entry angry and you have another angry that is all in lower case, or you have all angry that is all in higher case, the system, when doing pre-processing, will take them as different words. So there are some tasks that will require you to do to the case the input that you are given, but most of them start from tokenization. So you tokenize. What do you mean by tokenization? Meaning you split the sequence into smaller units of tokens. So what are those units of tokens? It's dependent on what type of tokenization you want to do. There is the character level tokenization, there is the word level tokenization, there is a sentence level tokenization. In a case where you are dealing with many documents, so each document consists of sentences, so you do sentence level tokenization. But there is also another that is called the subword tokenization. So as part of what the problem with other levels of tokenization is, you may end up with a lot of what in your vocabulary, and the model, especially newer models that have been trained, require a specific number of vocabulary, else the model will become very, very large, that it can either not be trained, or even if the training might take you a lot of time. So subword tokenization usually is a way of, it's an algorithm. There are different types of algorithms, such as right-pair encoding, sentence-based encoding, and the rest, that determine patterns in the text and then divide the text into those patterns. So if you go deep into natural language processing, you will see this type of tokenization. But then after tokenization, you are left with text. But we all know to process text using a computer, you require those texts being converted into numbers or numerical values. So those numerical values, as you've seen, I know in the previous modules, there are like many types of them, such as you have the vectors, you have whatever. So there are a lot of them. So, but basically encoding, what encoding does is take each token that you've split from the sequence and then represent it with a vector representation, especially of that token. So they said here embeddings are done in a way such that a similar meaning or words are used together. So words that have similar meaning or that are used together are clustered together. So if you take an embedding or you train an embedding, because there are many pre-trained embeddings that you can check from, you will see most at times words that have similar meaning. If you plot them in the vector space, you will see that they are there together. So you will see what fantastic, but also you will see what like bad and the rest. So they are all related to the word good, and then you will see them together, being clustered together. So those are embeddings, but embeddings are not the only way to represent text. There are many ways of encoding, which include one hot encoding, zero hot encoding, and the rest. So about embedding, so if you are doing NLP tasks, you know a tokenization, and you know there are different types of tokenization. You know what sentence encoding, meaning what do you encode? You change them from their textual values into numerical values. So through either one hot encoding, zero hot encoding, embeddings, and the rest. So the next is the part of speech untying. So usually part of speech is, you know what part of speech is, because we've all done that in our primary and secondary schools. So the essence of part of speech tagging here is to know the essence of which each word or each token in the sentence, so that when you are taking, let's say, doing sentiment analysis, you are more interested in the verbs, meaning what action is being taken, what emotion is being rendered. So getting all this meaning in words will help you determine what emotion, example in sentiment analysis, is conveyed. So in here you see Elizabeth here is a proper noun, verb is the was, too much is like quantifying embarrass. So too much embarrass is an adjective. There is to say a word and the rest. So these are all tasks that is involved when doing part of speech tagging, but also person. So person is knowing how each word relates to each other. So embarrassed, who is embarrassed? It's Elizabeth. How much is she embarrassed? Is too much. embarrassed. But why is she embarrassed? Maybe saying a word will make her feel embarrassed. So all of this contributes towards the model, or understanding what importance or what use a word have in a sequence or a sentence. So there is the word phrase frequency and engram. So all of this, they have their own application, and we'll see some of the application of these engrams when we come to do machine translation evaluation, especially. So others are part of pre-processing, and they are all in your module. Is noun phrase extraction, in analysis of sentiment, inflection, lemmatization, whatnot. So lemmatization, especially if you have words such as what should I? So bigger. So bigger usually will have the same meaning, although the GER will have, let's say, the quantification of how big something is, but the root word is big. So most especially models that do sentiment analysis, models that do summarization and the rest, and even translation, will require knowing that all of this what means the same. It's just that some words, if they have that GER bigger, meaning it's a lot of big, but the root word is big. So there are all of these words. Inflection, inflect is the root word. There is extraction, extract is the root word. So sometimes you need all of this lemmatization if you want to do some basic tasks. So especially with sentiment analysis, sometimes you just want to know whether something is either good or bad, or positive or negative. So you don't want to know how much it is good or how much it is negative. So if they said is big, is enough for you, not necessarily the bigger. And sometimes in your dictionary, you might find, or in the vocabulary of the model, you might find that it's only the root word that is present, not the bigger. So if it's just see the bigger, it doesn't know what it means. But if it see big, yeah, it knows big. So if you do lemmatization, you simplify the words into their root meaning. The model might understand better what you are even trying to find in. So and all of this have their own usefulness. The degree of usefulness is dependent on which task you are working on NLP. And if you read into the task, most especially, first read the basics before you even think of going either reading research or whatever. You will see how each of these pre-processing techniques help the task at hand that you want to do. The next is the libraries that you will come most especially across. NLTK. NLTK is Natural Language Toolkit, and I think it's one of the most important tools in NLP, because it provides you with almost everything that is basic in NLP. So you have parsing, it does parsing, it does part of speech tagging, it does tokenization, whatever tokenization that you want, there is it in NLTK, and a lot that NLTK does. So there is Spacey, there is Gensim, and especially this Gensim, when building language models or when building embeddings, especially, you may use Gensim to develop embeddings. I think the first time I used Gensim was in 2019 to develop the Hausa word embedding model, and since from then I've been using Gensim. It's very good. Scikit-learn, you all know Scikit-learn, sklearn. There is Stanford NLP. So these are all tools, but especially nowadays the transformers that are provided by Hugging Face. So transformers, if you will see later, transformer is a form of architecture that is used in machine translation, natural language processing, and the rest. But in here, there is a set of libraries called transformers that were created by Hugging Face. And in this, you have a lot of data sets, a lot of models, pre-trained models, a lot of everything that can be used for almost all natural language processing tasks. There is a text blob. I think text blob, its example is the one that was used in the module that you have. So the challenges in NLP. So we said NLP, or natural language processing, is the use of computer to process human language, process and understand human language. But human language comes a lot with a lot of should we call it differences, or its own structure, its own unit structure, that learning one language is a lot different from learning another language. So you have, let's say, language such as English that have 26 characters in addition to the vowels, but especially it have 26 characters in the alphabet. But there are languages such as Chinese that have a lot of characters. Some people are saying more than 1,000 or 2,000 characters that are, or alphabets that are used. So each language will come with its own structure. But they are specific to each language, or not even specific, but across each language, you have the idea, the challenge of ambiguity. So given a sentence, some sentences without the right context will be ambiguous, like even like to human understanding. When I read a text, it might mean a lot different to me than it will mean to another person. So we were doing some tasks on, or annotation, data set labeling on sentiment analysis. So you will give a tweet, because the sentiment analysis are trying to find out different sentiment on particular, let's say, language such as Hausa on Twitter. So you will give a tweet to 3 people. And if one person will understand that that tweet is negative, meaning it has negative sentiment. Another person will tell you, no, this tweet have positive sentiment. That same tweet. And another person will read that same tweet and say, no, this tweet do not have any sentiment, so it's neutral. So you see most of data which are unstructured, especially data set that are in Twitter, might not have the right context, or even some more structured even sources, such as sometimes I was reading some news content on Daily Trust, and I came across a lot of like grammatical errors, which I was like surprised. How can Daily Trust, as big as it is, will have these grammatical errors? So some of those might bring up ambiguity, or some spelling. So maybe in Hausa there is this words that have lankwasa, and the lankwasa was not used. So it might be ambiguous that, no, does that person mean this, or does? So this form of ambiguity is a very big challenge in NLP, how to sort out ambiguity. But there are also the recent data set that we created on Hausa visual genome, given a picture to solve the problem of ambiguity. So there might be an English sentence that say he is coming out of the court. We might bring maybe in our hearts that said he is coming out of the court. So that court might be court. Sorry. That might be kotu, but that might also be a court that is Lontanese is played upon. Or that might be another court. So you see, without seeing the picture, where is that person actually coming from? Sorry, let me take my daughter away from this, sorry. Sorry. So context and co-reference. So there is also an evolving area in sentiment analysis, in which you not necessarily the whole text you want to find the sentiment of a particular entity in that text. So let's say they said Idris is a bad person while Shamsuddin is a good person. So in searching that, you might take care that sentiment, what is the sentiment in that particular tweet? You might not see, you cannot find it, because one of the sentence is saying one person is good, one sentence is saying somebody is bad. So, but you want to find that good. Is it used for Shamsuddin or is it used for Idris? Because they are different entities, Shamsuddin and Idris. So to get the exact reference of the word in the sentence, which entity is it referring to? Sometimes it can be challenging. So also words that are not in the vocabulary. So most models, as I told you, when you split those words, you are like building a dictionary of vocabulary in which each dictionary is represented, a dictionary entry, which is that word or that token, is represented with its own vector representation after you compute the embedding. But there might be words that are not in that vocabulary of that you just created. So how do you deal with that? It's also a problem in NLP. So lack of annotated data. Most of languages in Africa, most of low resource languages do not have data. So how do you deal with that? It's also a challenge. So cultural and linguistic variation. So you might have a situation where in a certain culture, this is how they say this, and it makes meaning. While in another culture, you might not even know how to put that. So let's take idiomatic expressions in one culture. So in Hausa, if they said, if they do something of like, let's say habaici or karim magana, how do you get to translate that in English? Or how do you put it in English? Because natural language processing usually does with mapping of their, if I see this represents this in this. So if you take normal, let's take translation as an example. If you take normal translation, is if I see good, it means kyau. Whatever I see good, it will try to map it with kyau in Hausa. But how about if that good is used in a way of habaiji? So the exact translation will be a lot different, but how do you know? How does the model know in natural language processing? So this like just the basic introduction to how what is natural language processing, its applications, its challenges. But then translation. So what does translation mean? We all know translation. You might be like maybe involved in one or two situations where somebody expects you to do translation. You might read something in English. So to understand it better, usually, how do you take it? If I say a very hard problem, when I want to understand this, because I'm a Hausa man, in my brain, usually I will translate it to what does this mean in Hausa, so that, yeah, I get especially what it is. So translation, changing a text exactly in one language into another language. And how do we mean by exactly? Usually preserving the meaning. So if I say a very hard problem in English, how can I change this into Hausa that will mean exactly the same? So translation usually is a very hard problem. And what makes it hard? These are some of the points that make it hard. They are not exhaustive, but I think they will pass the information on why translation is hard. So language complexity. So most language have different grammar rules. They have, some language have idiomatic expression. Some language, how you understand it in this language is different from, so there are instances where you go, let's say, to a certain country and somebody will talk and you will see other people that are native to that place will start laughing. But then you will just be looking at them, like, how are you laughing just because he said this? It's a cultural nuance. They are the only people that know what that means. So you might not be laughing. Maybe you might join them in laughing, but it won't come like spontaneously because you don't know what it means. So there are ambiguity, which we've said that in phrases and words can have different meaning depending on in which context they appear. So there are language pair variations. So how you will translate between Hausa to English is totally different from how you will translate between English to Arabic. So if you say I'm translating from Hausa to English, and then I'm translating from English to Arabic, that does not mean that you are translating between Hausa to Arabic will be the same among this. Because since I said I have translated to English, then I have translated English to Arabic, translating from Hausa to Arabic. So yeah, this is a different task. Or some example, take a model, let's say Google Translate. It's an exercise that I will give you. Try to do this. Take Google Translate, give it translation from Hausa to English. Take that English and translate it to Arabic, and then keep the Arabic. Then take Hausa and translate it directly to Arabic. And you will see that the translation will be different. So language pair, usually to do their translation, there are some accommodations that you may have to do because they are totally different between how you translate two languages. So there is a cultural and conceptual difference, which we'll see. There is a lack of parallel data, which is also a problem in NLP. There are domain-specific challenges. So you might have a translation model, let's say Google Translate. If you give it, let's say, a paragraph in premium times, you will see the translation is good. But take something in, let's say, physics, and put it in Google Translate, you will see that the translation will be a lot useless because of this domain-specific challenges. So when you are translating between technical terms, sometimes even the human person might find it difficult, talk less of the model. Even the human expert, not even keep it to the human person. The human expert might find it difficult in translating some technical terms. So talk less of a model. So other challenges include the quality and subjectivity. So quality and subjectivity in this instance might mean, so I give you translation, I give another person the same sentence to do translation. If you do not see this translation that you are doing, and especially let's say the translation involves, let's say 10 words in English, the two of you will generate different translations. Two of you will use different word choices when doing the translation. So that quality might bring up. It might be they are both qualitative, but it might also be that they are the one is more qualitative than the other. But that even quality might be subject to what I want. So one person might see one and say this is more qualitative than the other, and another person will see it and say no, this is more qualitative. So those challenges in translation. So real-time translation also is a lot of, so you might see some transcription at, let's say, United Nations or wherever where you have multilingual people. So doing translation real-time, you will see another person talking for, let's say, 5 minutes, but the actual translation that the person is given might just be 2 minutes because the person is just trying to summarize. So real-time translation is also a problem, which also and most of these things that I'm pointing either in NLP or in translation that we are saying are problems are usually research problems that people are investigating on, trying to find out the best way to reduce this problem. How can I reduce quality and subjectivity issue? How can I make translation more real time? How can I make transcription, changing converting speech into text more real time and whatsoever? So these are all problems that. So now what we will see is what tools and methods are used in translation. So under this, we'll see translation modeling, quality evaluation, and the tools that are used. Especially, there are many tools. What I just bring are just a sample of the tools. So translation modeling. So how do you model a translation model? There are a lot of ways, but we'll see. So we have statistical machine translation, and under statistical machine translation, you have examples such as the rule-based MT, you have the phrase-based MT. So these are various methods of writing or creating some rules that will determine how you do translation. So example, let's say in phrase-based translation is, if you see there is word-based translation, which we all know. So let's say take an example of English sentence, and you go and find each word, you give it its own translation, and you join them together. At the end of the day, you might create something that is not meaningful. So let's say I feel happy. I think it's one of the example that is given in the module. I feel happy. So if you want to do word-based translation, I usually in Hausa is ni. Feel is jin, or ina jin, or yeah, let's say jin. And then happy is murna. So ni jin murna. So if you take like this are just 3 words. If you take a log sentence, such as sentence that have 15 words, and you do this individual translation, you'll just be laughing. So instead of word-based translation, so people came along with phrase-based translation. So first, what you need to do is to extract the phrases inside the sentence, and then you will have a table that will match those phrases. So if I see this phrase, I will go and look it up in this table, which is called the translation table, and then using that you'll substitute. So these are phrase-based, but rule-based is some form of rules that if I see this, the rule in translation, especially linguists know the rule in translation between, let's say, Hausa and English, I will craft that rule. But also, if I want to translate between Hausa and Arabic, which is totally different, I have to sit down and create another set of rules, because as we said or explained earlier, language pair variation. If you have 2 language pair, they might have different ways in which you generate their translations. So you will have this problem when executing this. But then there is example-based machine translation, where usually, let's say you have a repository that have a lot of translations. So when trying to generate a translation, you look up your previous translation memory, which is the previously created translation, and you try, or the machine tries to use that and then generate its own translation. Then there is a statistical alignment, that whenever I see, let's say, A in the position A, maybe A will appear also in position B in the second language. So trying to align what statistically is also another way. But nowadays, how we do translation is using the last approach, which is called neural machine translation. So what is neural machine translation? So it's just the use of neural network, which I know you've not covered, but I know you might have come across such term called neural network. So neural network are just set of networks that when you give it input, and the input are just sort of like, let's say, signals, it tries to give you an output. And that output might be dependent on the input first, but also the importance that is attached to that node in the neural network. So that importance is called the weight. So some models might have, let's say, a weight of 0.5, while others might have, let's say, a weight of 0.005, because it's not that important at that computation time step. So, but you may, if you like, you may read more about neural networks and then neural machine translation. But also under neural machine translation, there are some sort of architectures, such as the recurrent neural machine translation. There is a convolutional neural machine translation, and then there is the state-of-the-art transformers architecture. As I have mentioned earlier, there's a transformers, a library, but there are transformers that are actual architectures of neural machine translation. So what does transformers do? But basically, what does neural machine translation do? It does not rely on all of these previous steps, saying I have to write rules by myself, or I have to extract a phrase table and then try to look up in dictionary, or I have to look at previous generated translation. No. What neural machine translation does is, if you give it examples of translation, it tries by itself to learn the rules by itself, the rules of translation. so that at the end of the day, if you are given it, it doesn't need to know that exact sentence that it is supposed to translate, because it has already determined from previous example during the training of the model that if I see this word, it's supposed to be translated by this word, especially taking care of the context also, which we've explained before, the context because of ambiguity and the rest. So recurrent neural machine translation is one architecture that started to do this. Then it evolved into convolutional neural network. Most times, or say previously, convolutional neural networks are used on image data, but then it got introduced into machine translation, and usually they use instead of two how do they call this? Instead of two-dimensional convolutions, we use one-dimensional convolution because it's a text on machine translation. So, but then it resulted into transformers, and transformers was first introduced in 2017, and up till now, there is nothing that is as good as transformers. You may decide to read the paper or look at more research on transformers, but transformers is state of the art. It removes all of the inefficiencies of the previous ways to do translation, but not only translation, to do general NLP. So transformers is just the state of the art, is very good at generating or executing natural language processing tasks. So how do we evaluate the quality of translation? So there are automatic metrics that you may use, and there are also manual metrics or human evaluation, as we call it in machine translation. So the most commonly used metric is the bilingual evaluation on the story that looks at n-grams between the prediction. So if I generate translation, it tries to compare it with the actual human translation that was created as reference. So that it will evaluate to see that model that generated the translation, how well does it work on data set that it has never seen. So in bilingual evaluation on the story, we talk about 1 gram, 2 gram, 3 gram, 4 gram, and it will try to match all of this statistically to determine the actual performance of the model. There is translation error rate, there's word error rate, there's character frequency, there are all of this that you may find. But there is a human evaluation that tries to see how fluent a translation is and how adequate. What we mean by adequate is does the translation adequately translate the actual source sentence that you are given. If you are given sentence in English and you are translating to Hausa, so that Hausa translation that was generated, is it adequate? Does it adequately mean what is represented by the English translation? And also, how fluent is that? So yeah. So the last part I think that we are seeing is the translation tools. Translation tools, this I mean by manual translation tools. There is a computer-aided translation. There are tools that assist translations to ensure consistency in what, as I said during my earlier presentation, is if you are given different words, I give the same sentence to two different translators. At the end of the day, they might give me two different translations, which usually when training model, that's not what you want. You want consistency. So there is post-editing, meaning after the machine translates, how do I correct that translation? So there are many tools also. So example of these tools that enable both assisted translation and post-editing include the Trados, MemoQ, MemSource, Omega, Midcat, and the rest. There are a lot of them. So to conclude this presentation, what we saw that is NLP is applicable to every aspect of human life. Every aspect, from subtitling if you are a film addict, to this accessibility in our phones, where you can, if let's say for people that do not have hands, they can dictate whatever they want using speech recognition, text transcription, and the rest. So to do NLP, it involves various techniques, especially tokenization, parsing, and the rest. There are a lot of them. noun phrase extraction, etc. So there is the also the common applications include translation, disease diagnosis, sentiment analysis, and the rest. We saw all this during the course of the presentation. And there are many sub-areas. Sub-areas include name entity recognition, text generation, in which you tell ChatGPT, please generate an abstract for me under this topic, and it will generate something nice. So this is text generation. But there's also document summarization. You want a large body of text to be summarized, you can give, use this to do that. And also NLP and all of its subfields are active area of research. So there are many research endeavors that are going into either making them much more easily accessible, but also making them like much more qualitative. All of those challenges that we saw, all of those problems, how to solve them, there are a lot of research that is going in there. You may decide, those of you that have done your BSc in computer science or whatever, you might decide to go into, there are people I know that in this cohort that are into engineering. Into engineering, you can do NLP. You can, in medicine, you can do NLP. In social science, you can do NLP. So wherever you are, you can do NLP. So thank you. And this is the end of this presentation. Marlon Simon.
Oh, okay. Thank you very much, Doctor, for this wonderful presentation. I believe we really enjoyed it, and we have understand this your presentation or the NLP area very well. So I think we have like 6 more minutes. I don't know if Doctor is willing to take 2 or 3 questions from the audience before.
Yes, inshallah. I hope the questions I can answer.
No, haba, inshallah. Okay, to fellows, well done. So please, if you have any question, I think you can raise up your hand and or just unmute yourself and talk. I think just 2 or 3 questions before we go. Thank you so much. Question you indicate by raising up your hand, and then we'll allow you to ask your question. We really enjoyed the session, so I presume that we have so many questions to ask. So yeah, you are free to start asking your question.
Maybe there are things that I may not have touched. Maybe there are things that I have touched, but not quite in depth. So you may ask whatever it comes to your mind. If I don't know, I will try to get something, and then I will share with you. So your question might be answered here or might not be answered here. So we are all learning. So please, if you have any question, you can ask.
I think Abdul Jalil dropped, is it? Yeah, Abdul Jalil dropped, I don't know, is it a question he dropped in the chat?
Abdul Jalil.
Yes, I think.
Can we get the slide? Is that?
Okay, let's, yeah.
Yes, there is, how do we do with the lack of data set in Nigerian language if someone wants to make analysis? So Abdul Jalil, I suspect that you've been following us, especially during our the Ariwa Data Science submissions to Cohere Hackathon. And part of what we tried to do in the submission, I think that Lukman submitted, was trying to get data set automatically aligned from a large collection of data. So sometimes there are a lot of these ways that you can do actual synthetic creation of data. So synthetic means automatic. You can use automatic ways of creation of data. But if you have the wherewithal also, you can expend your money to create some of these data sets. So what we've been doing in House NLP especially is trying to make this data set available so that most of our local researchers, if they come to work on NLP, they will not just be working on NLP, that matters to other jurisdictions or other climes, but using our own data sets to be solving problems that are related to Hausa language. So towards this, we've generated a lot of resources, such as the Hausa word embedding. We've generated the Niger Senti data set for sentiment analysis, expanded it to AfriSenti, covering almost 14 African languages. We are currently working on AfriHate, which is for hate speech detection. We've generated the Hausa visual genome. We've generated and it will publish in a matter of time data set on visual question answering. There is a data set by Saminu on hate speech detection on Fulani. So there are a lot of these data sets within the Hausa NLP that we are trying to create. And most of it here, we spend money to create so that of incoming researchers, if you are working on NLP, you will be using those data sets to solve data problems that relate to Africa and our languages. Yeah.
Thank you so much, Doctor. I think we may take one more question from Awal. Awal Khalid, you raise up your hand. Can you speak?
Yes, sir. Good evening, everyone.
Good
First,
evening.
I would like to thank Doctor for his wonderful presentation. We've really enjoyed the session. Thank you very much, sir. And secondly, I want to put a request to the doctor whether we can get the slides he used in the presentation. Yeah, that's just it.
Yeah.
Thank you very much.
So I suspect whatever we do in Hausa NLP is open source to our cohorts or our students, but not only students, but members of the Hausa NLP group, members of Arewa Data Science. So I will forward this to Shamsuddin, and he will make it available to all of you guys, inshallah.
Thank you, sir.
No, thank you. Please, can you lower down your hand? And I think, Brahman, you can go ahead.
Okay. Assalamu alaikum. Okay. I can say good evening all. So we are very happy and with this wonderful presentation. My question or my request, we as just beginners of the machine learning, I would love Doctor to have to present a mini project so that we the beginners will know where to start. Maybe in the next office hour.
So thank you for this suggestion, but we've been discussing this with Dr. Shamsuddin on the because we organize a shared task on sentiment analysis, and we have a lot of teams that participated from Hausa NLP, from African community, from the world, research groups at large. So some of the submissions created state-of-the-art performances on our languages, because the data set is on AfriSenti, so there is Hausa, Igbo, Yoruba, and the rest. So we try to talk among ourselves that most of this state-of-the-art processes, if we can give the community here in Arewa Data Science so that you can replicate, because some of them come with codes. So even that you are not developing the code, but you are implementing the task, you are seeing it output, you are seeing how good it works, it might spring up, let's say, an idea or two that you might want to work on, or you might find it, take it interesting that you want to develop on that field, and you might start reading, start doing all of these short courses, watching videos on YouTube and the rest. So we've not finalized that, but if we finalize it and it's feasible, we'll make it available to you so that you can try to replicate all of those state-of-the-art systems and to see their output yourselves. And most of the data sets are local data in Hausa. Those of us that understand Yoruba also, there are data in Yoruba, Igbo, there is data in Igbo, there is data in Nigerian Pidgin. So there are data sets that you can relate with So if you read it and the output, it makes sense, you will say, yes, it makes sense. So not necessarily only English, because here we all can read and understand English, but there are data sets, let's say in French, in German, that some of us might just be working on and relying on the automatic metric to say, yeah, my system performed 80% or 90%, but you don't know actually what that 80% means. But if it is in Hausa and you read it, you say, yeah, actually this is 80%, or no, this is not 80%. Maybe the model is, the evaluation metric is not all that good on that data set. So it's a data set that you can relate with. So if this is finalized, maybe during your mini project, you can work on doing that implementation. And maybe if you like, also, you might look at improving some of the methodologies if you like. But sometimes even implementing only is a starter to achieving a lot of wonderful things in life. So we'll maybe before doing your mini project at the end of this cohort, we may have finalized all of the discussion, and if it is feasible, then you will just do it. Yeah.
Thank you, Doctor. I think we are already ahead of the time. But
yes, I think
one more question.
Lukman, you asked lemmatization. I think
lemmatization, yes.
Please Google what is lemmatization, and you'll see lemmatization is just simple. If we have, let's say, what should greater. So greater, its root word is great. So lemmatization will try to find what is the root word of greater. So it will say, yeah, it's great. So that you lemmatize. So lemmatization is trying to find the root word given a word. So bigger, as I give example, the root word is big, B-I-G. So what lemmatizer will do for you is to tell you that this is the root word of this word that you give. So there are words in English, let's say good, better, best. So if you have better, the root word of better is not bet, it's good. So some of these things in English will require you doing that. But there is makarantu, makaranta, and this. So lemmatizer will try to find you that the root word of all of this is makaranta, getting the root word. So that's like summarily what lemmatizer means. But please Google lemmatizer. I think there is even a lemmatizer that was developed for Hausa language. I've forgotten the authors that did that, but actually it's there. If you Google Hausa lemmatizer, you'll see a paper that is written on that. So Samina.
No, thank you, Doctor. And I think we have come to the end of this session. We really enjoyed this presentation, and we hope next time when you are presenting, you include some little quotes so that we have a better understanding, especially in the area of this, this pre-processing of it. So without wasting much time, I can say thank you all, the presenter and the audience. Thank you so much. See you on, that will be Saturday, right? Yeah, thank you so much.
Okay, so thank you. See you.
Yeah, bye.